Going on to topic 2 of chapter 9 now, we're going to take a look at simplifying radical expressions. This is some of the operations that we do with them. And you could just read these over. This is what we're going to do. Alright, now again, you want to take notes on these, and this first one here has to do with what are called the properties of square roots. And this first property is that if under the radicand this, remember, is a times b, it's not a plus b. We said you couldn't separate when it's plus, but if it's multiplication, then the rules change a little bit, and we say we can separate this product into its factors. So this would become the square root of a times the square root of b. So that's legal if it's multiplication. And that's, we mentioned this earlier, that you could take a fraction that's under a radical sign and divide it into the two parts. So we said that was legal. Okay, some background. Now, when we are to simplify square roots, we want to leave it in such a form that the radicand has no perfect square factors left in it. And we'll illustrate that here. Now, the book and the PowerPoint slides go through this very well too, but I'll give you a little lesson here as well. So we have the square root of 48. Now, we don't see a perfect square factor there right away. So what do? Well, a technique that you may or may not remember is to find the prime factorizations of this. Since this is even, we know a 2 will go into there, and we get 24. This is even, so a 2 will go into there, and we get 12. And a 2 will go into there, and we get 6. And a 2 will go into there, and we're left with a 3. So these are the prime factorizations. So as we look, we have 2 times 2 times 2 times 2, which is 16. All of these make up a 16. So 16 times 3 here is going to be 48. So the strategy I strongly recommend, you have to simplify something like this. So make 2 radical signs. Now, under this first radical sign, you're going to put the largest perfect square factor of this, which is 16. And then the other factor is a 3. So there's no more perfect square factors left here. So this then becomes 4, the square root of 3. Alright, now your textbook authors, they show this as well. So let's just follow it through a little bit here. Okay, now let's do this 63. So I know, for instance, that 63 is 9 times 7. and 63 is the perfect square factor. Now I could have done a prime factorization over here, but if you know something like it, this is the easier way. So this is just going to be 3, the square root of 7. So we are simplifying radicants here. And what's left under the radical sign, there are no more perfect square factors. Now, for something like this, and again, you're writing these in your notes. This is example 1, part C. We can put this under its own radical sign, and this under its own radical sign. Now, we know this one already is going to be a 4. But here we want to divide it into those that are perfect square factor, largest one, under this radical sign, and what's ever left. And perhaps you could see 25 times 3. So this will be 5. I'm writing before my mind catches up here. 5, the square root of 3, over 4. And that's how we get it. Okay, now when we have variables, and again, this would have to be a positive value. So using the absolute signs indicates it's going to be a positive result. Has to be greater or equal to 0. So the square root of x squared is x. And why is that? Well, let's take a little background here. We have the square root of x times the square root of x. That's going to be the square root of x squared. So, what two values of x, exactly the same, multiplied together, gives you x squared? And the answer is x. Now, I'm going to show you this. This is a little bit ahead of the game here, but let me just show you something here. This radical sign, we said, has an index number that we don't write, and that's a 2. And this x here has an exponent that is 2. Now, another way to write this radical expression is to convert it to its fractional exponential form. So we take the radicand x and its exponent. We take away the radical sign, but the index number becomes the exponent, part of the exponent, as the denominator. Now, that's true for any index number in regard to the exponent of the radicand. The exponent of the radicand becomes the numerator. The index number becomes the denominator. Now, what is this equal to? Well, it's equal to x. 2 over 2 reduces to 1. So x to the first, but we don't write the first. So that's another way of doing this. And we'll check it out here as well. So, keeping in mind that when both are perfect squares, the square root of 16 is 4, and the square root of y squared is just y. Because if we squared this, we would get 16y squared. So the square root of this then would be 4y. Now, for something like this, again, we're looking for the largest square factor of this here. And if we aren't sure, we could always do this. We can divide a 2 into that, and that goes 36. And there, look at that's a perfect square. So this is going to divide into a simplified form where we put perfect square values under our first radical sign, which is going to be 36. And we know that a squared is a perfect square. And then we're left with 2. Square root of 36 is 6. Square root of a squared is a, the square root of 2. And they'll show it to you as well here. Okay. And there's the answer. Now, how about this one? Again, you want to develop a strategy, so we're going to put 2 radical signs. And under the first radical sign, we're going to put all the perfect squares of 12. The largest one is 4. Then what's not a perfect square is 3. And then these are both perfect squares. So this is going to become 2xy, the square root of 3. We have simplified that. Okay. Now for something like this, we're on example 3. You should write the example numbers down in your booklet. 3a. So again, under one radical sign, the perfect squares. Well, actually this one is a perfect square. So this is going to give us the square root of 81 is 9. And remember there's a 2 there. We take it away from the radical sign, put it under that, and that reduces x to the second power. And again, that could be a plus or minus, but we're looking for the principal square roots here. Okay, now here's one where we don't have all perfect squares. So again, we're going to use that technique. Radical sign, radical sign. Now 64 is a perfect square. Now of x to the 5th, what would be the perfect square there? Well, any even power, so that's x to the 4th. Now we had one x left over that we'll put there, and of course the y goes there. So now this is a perfect square, 8 x squared, the square root of xy. Good technique. Okay, for something like this. Now hopefully you're developing a strategy here. 2 radical signs. What's the perfect square in 18, the largest? Well, a 9. And you're left with a 2. That's not. This is a perfect square. And this is a perfect square. So, square root of 9 is 3. I'm dividing the 4 by 2 and get a to the second. Dividing the 6 by the index number 2, get b to the third, the square root of 2. Now remember, you can always pause and go back and study. Okay, now for something like this, and some of this you could do mentally, but we'll write it out for you. So for the top, I want to put all the perfect squares under one radical sign. And that is 9a, the closest even power is 12. And then there's an a left over. So this times this would give you a to the 13th. So this is going to be 3, and then divide this by 2, a to the 6, square root of a, all over b squared. Remember, you're taking that 2, take away the radical sign, put it under the 4. 4 divided by 2 is 2. Okay, now here we're going to look for a similar process, but now cube roots. So, let's set our radical signs up. Cube root. Now, under this one, we only want perfect cubes. And under this one, we're going to have anything that's left. And remember, you have to put your index number in there. So if we had 54, we're not sure what they were, we could divide by 2 and get 27. Now there's a perfect cube. So 27. Now, for your variables, any multiple of 3 is a perfect cube. So this is a perfect cube. But notice we have a 2 left over there. And I have to put my x in there as well. Yeah, there we go. So take the cube root of this, which is going to be 3. Now we're going to divide our exponent by the 3 this time and get x squared, the third root of 2. And there's the answer. So a similar technique, but we're using cubes here. Using that. Very good. Okay, now you might think, we have a negative sign under our radical. But again, if the index number is odd, that's okay. But we're looking for any perfect cube we might have there. So we have a 40. We'll get to the negative sign in a minute. So that's 2, 20, 2, 10, 2, 5. Oh, we have 8 times 5 is 40. And we could then have that like so. The third root, again, we want perfect cubes under this one, and whatever's left under the other. So I'm going to put here a negative 8, and then I'll put a 5 over here, because negative 8 is a perfect cube. Now, we want multiples of 3 here. So the closest is going to be x to the third, with an x left over here. And this is going to be y to the 12th, with a y left over here. So now we have perfect cubes, which then becomes a negative 2x y, and we're dividing this 12 by 3. So that's to the 4th. And then the third root of whatever's left over, 5xy. And there's the answer. And again, we're showing you how this works. And they're showing us the same. That's good here. You almost think that I watched this before. Well, I took a quick look at it, but I don't remember it. But I know what they're looking for. Okay. So again, our technique is to divide this into perfect cubes under the first one, and perfect cubes, whatever's left over here. There's no more. So I know that if I divide this by 2, I get 125, which is a perfect cube, and then I have a 2 left over. I need multiples of 3, so this is a to the 6th, with a to the 2nd left over, b to the 9th, with b to the 2nd left over. So now these are perfect cubes, and this is everything that's not a perfect cube that's left over. So this is going to be 5, and now we're dividing these exponents by 3. A squared, b to the 3rd, the 3rd root of 2a squared b squared. And that's my answer. Okay, we just went over 20 minutes, so I'll pause here in case you want to do any of these. And then these are the answers. So you could pause and do them, but you have your practice and certify, and that's what we do and what we grade you on. But we do have a grade for your notebook. All right, let's pause here.